Hello friends. Today we are going to talk about radicals. This is another IB lesson. Well, first of all, we shall deal with the square root. The square root of 9 is equal to 3. It has the index 2 here because 9 is equal to 3 times 3, which is 3 squared. Since this is the simplest root we can see, we do not write this index. We write simply the square root of 9 is 3. Another example. The square root of 64 is 8 because 64 is equal to 8 times 8 or 8 squared. Keep in mind that if you have two square roots multiplied, for example, square root of 5 times the square root of 5, these two eliminate and the result is simply 5 because square root of 5 multiplied gives square root of 5 to the power of 2, which is 5. Well, let's go to another root. It's the cubic root. Here we have the index 3. The cubic root of 8 is 2 because 8 is equal to 2 times 2 times 2 or 2 raised to the power of 3 or 2 cubed. Well, also you must keep in mind that if you have 3 cubic roots, for example, cubic root of 5 times cubic root of 5 times cubic root of 5, these three give simply 5 because all this is cubic root of 5 raised to the power of 3, which is 5. Well, these are the basics. Well, we can of course continue fourth root, fifth root, etc. Generally speaking, theoretically speaking, the nth root of number a is equal to number x if a is given or is equal to x to the power of n. Well, mathematically speaking, according to modern mathematics, this number here, a, which is under the radical, should be greater than or equal to 0. Well, okay. Now, some roots lead to rational numbers and some other lead to irrational numbers. Let's see an example. The square root of 16 is 4, which is rational. But if you calculate the square root of 12 and you put this on your scientific calculator, it gives something like that: 46, 4, etc., an infinite number of decimals. This is an irrational number. The thing is that how do we simplify such irrational numbers or such roots? Well, there is a way to do that. I'm going to show you. Now, let's start with the square root of 12, which is an irrational number as we saw before. What we do first, we take number 8 and we factorize it near this line. Okay, 12 divided by 2 gives 6. 6 divided by 2 gives 3. 3 divided by 3 gives 1. This means that 12 is 2 times 2 times 3. So, the square root of 12 is square root of 2 times square root of 2 times square root of 3. These two, as we saw before, eliminate each other and we take 2. So, the square root of 12 can be written in a simpler way, which is 2 times the square root of 3. Let's go to another example. What about the square root of 32, which is also irrational? We take 32 and divide it by 2. We get 16 divided by 2. We get 8 divided by 2. 4 divided by 2, 2. And that's the end. Okay, now the square root of 32 is square root, square root, square root, square root, square root all of them multiplied. So these two eliminate and give 2. These two eliminate also. So what is left is 2 times 2 times square root of 2, which is 4 times the square root of 2. Okay, let's go to another example, which is a bit more complicated. It's about the cubic root. Cubic root of 54. What we do the same strategy. Factorize 54. By 2 we get 27. By 3 we get 9. By 3 we get 3. By 3 we get 1. That's the end. So these 3 cubic root of 3 eliminate, and we get a simple 3, and this is the cubic root of 2. So the cubic root of 54 can be written in a simpler way like that: 3 times the cubic root of number 2. Alright, let's go to a more complicated example. We have an expression like this. We have to simplify this expression, the square root of 48 plus the square root of 75. Okay, let's factorize these numbers. 48 divided by 2, 24, by 2, 12, by 2, 6, by 2, 3, by 3, 1. All these two give 2, these two give 2, so it's a simple square root left here. So the square root of 48 can be written as 4 times the square root of 3 here. Well, what about 75? 75. Okay, we analyze 75. Factorize. By 3 gives 25. By 5 gives 5. By 5 gives 1. So these two give a simple 5, and we have a square root of 3 left. So the square root of 75 can be written as 5 times the square root of 3, and these two add and give 9 times the square root of 3. This is, of course, simpler than that one. Okay, let's get to another example which contains cubic roots. Okay, this is our expression. So we factorize 54. By 2 we get 27. By 3 we get 9. By 3 we get 3. By 3 we get 1. So this is 3. These 3 eliminate. So what we have from cubic root of 54 is 3 times the cubic root of number 2. And we can take also 16. By 2 it is 8. By 2 it is 4. By 2 2, and by 2 1. So these 3 eliminate and give 2. So we can write 2 times the cubic root of 2. This is the cubic root of 16, and the cubic root left here. So what we have here is 3 times the cubic root of 2 plus 2 times the cubic root of 2, which is 5 times the cubic root of number 2, which is much simpler than this one. Okay, now before we go to more complicated examples, I shall show you some rules of radicals. Rule number 1: the nth root of a times the nth root of b. If these indexes are the same here, you can put them under the same root, a times b. Remember that you can't do it if these two numbers are different. Well, the same roots holds for the division or for a fraction. If these two indexes are the same, so you can write the nth root a over b. Okay, that's the first rule. The second rule: if you have a radical like that, the nth root of a raised to the power of m you can write it without a radical this way, m over n. This is a raised to the power of m over n. For example, if you have fifth root of 2 to the power of 3, you can write it 2 to the power of 3 over 5. The fifth root of 2 to the power of 3, we can write it as a power. Well, the next rule, if you have two multiplications here, and this is n times k, this is m times k, you can simplify here, and you can write n to the power nth root of a to the power of m. For example, we have the eighth root of 2 to the power of 6. What we have here, this is 2 times 4, 8. This is 2 times 3, so simplify these two numbers here, we get the fourth root of 2 to the power of 3. The last one is the chain rule. What is the chain rule? If you have roots followed by one another, one under the other, you can simply multiply these two, which means that we get n times m root of a. For example, cubic root of square root of 8 is, here we have an index 2, so 3 times 2 gives 6, which means that this is the sixth root of number 8. Okay, now let's go to a more complicated example using these rules. Well, let's see an expression like that. It seems difficult at first sight, but if you apply the rules, you will see that it is easy. First of all, we can change all these to exponents, which means that this is 2 to the power of 4 over 3 times 2 to the power of 7 over 4 times 2 to the power of 5 over 6. So we apply the rule of powers here, which is 2 to the power of 4 times 3 plus 7 times 7 over 4 plus 5 over 6. Well, the next step is to make them change these to a common denominator, which means that 4 over 3 plus 7 over 4 plus 5 over 6, the least common multiple of these denominators is 12, so I put 4 here, 3 here, and 2 here, and which becomes 2 to the power of 16 over 12 plus 21 over 12 plus 10 over 12. As you can see, this is rather complicated. Okay, it always leads to a correct example if you're careful, but this is a bit complicated. I'm going to show you a simpler way to do that. Which is the simpler way? I'm going to show you that simpler way now. Well, I have the same expression here. This is index 3, this is index 4, and this is index 12. I'll change all these indexes to be the same. So the least common multiple of 3, 4, and 6 is 12. So I can multiply this by 4, I can multiply this by 3, and I can multiply this by 2. So now this is 12, 4 times 3, but remember, you must also multiply this. 4 times 4 is 16. The next root, 3 times 4 is 12, 3 times 7 gives 21, times 2 times 6 gives 12, 2 times 5 gives 10. Now we have the same indexes here, so we can write the 12th root of 2 to the power of 16, 2 to the power of 21, 2 to the power of 10, and easily we can write add these three according to the rules of exponents, which gives 47. 12th root of 2 to the power of 47. Okay, this is an easier way to do it compared to the previous one. And our last example. Oh, before we go to our last example, I have to remind you something. And when you try to simplify radicals, you have to keep in mind this. For example, how do we simplify this radical here? Well, 8 and 4 can be simplified to give 2 and 1, so this is simple, a square root of the square root of a. But if this is vice versa, which means that we have 4 here and 8 here, what happens in this case? Well, simplify, this is 1, this is 2, so we don't have to write this anymore. We write simply a to the power of 2, or a squared. And our last example in our presentation is this expression. How do we simplify this expression? Well, this seems to be the chain rule, but we have a problem here. The problem is this number shouldn't be here. To apply the chain rule, you mustn't have numbers between the roots. So the first thing is to put this number into this root here, into this radical. And how do we do that? We simply write cubic root of 5th root. I write number 2 here, and if I try to put this number 2 into this radical, I have to raise it to the power of 10 or 5, of 5. So now I can apply the chain rule, which means that I have 15 power, 3 times 5 gives 15, 2 to the power of 6, and I can also simplify this. This is 3 times 5, this is 3 times 2, simplify the 2's here, the 3's, and I have 5th root of 2 to the power of 2, or 5th root of 4, which is much simpler than this expression here. Thank you for watching my video.